In this lesson, we're going to be talking about compound inequalities. And compound inequalities are the conjunction of two or more inequalities joined together with either and or or. And we're going to be talking about both of these different types of compound inequalities during the lesson today. But let's just take a little general overview at and or. Let's first start with and. So what you see here is a graph of an and compound inequality. And you can see that the graph is a line and it connects two dots. And it doesn't really matter whether the dots are opened or closed. They still mean that either that point on the line is either included or not included. So that same meaning behind an inequality still is represented here. But the key to know about and inequalities is that it represents the intersection of two different inequalities, which can often be represented by this symbol that you see here. And let me just show you kind of what I mean here. So the intersection of these two, or of two inequalities would create what you see here. So for example, I'm just going to go ahead and write it here below. I could have an inequality that looks like this, and then I could have an inequality that looks like this. Remember, compound means we're looking at two different inequalities. And you want to notice where those two inequalities will intersect. And I'll change my pen color here so that you can see it a little bit better. But they're going to intersect right here. Right at that point right there. I'm just trying to highlight it. So if I were to lay these two inequalities on top of one another, that's where they would intersect. And those two inequalities would create what you see up on the number line here. So that's what it means by an and compound inequality. Now, the or is just a little bit different, and let's go ahead and look at that now. Or is the union of two inequalities. And basically what the word union means is that when you represent your inequality on your graph, you must account for all of the points that are represented in both of your inequalities that you're using to solve the problem. So what I mean by that is, one way that you could see an answer is the first one, where you have an inequality you can see here going to the left, and then you have this one going to the right. And these are just, again, compound, meaning two or more inequalities, in this case two, and both of them are represented going the other opposite direction. So you need to account for all the points on both of those inequalities. Now, the union of the one below is a little bit different. So I'm just going to go ahead and draw a little picture here. But you could have one inequality that is represented like this right here that I have above. And then you could also have one that is represented like this. So those could be your two inequalities. And if I want to represent the union between those two graphs, meaning I have to account for every point on both of those two inequalities, well, then I would end up just drawing one inequality, which is the one that I drew in red here. Okay, so that's what union means. So we're going to be taking a little bit closer look at these two types of inequalities as we progress. But I do also want to mention that the symbol for union is a U, which makes it kind of easy. The way I remember the symbols is union is U, and that's or, and then the other one is and. All right, let's go ahead and look at some problems. We're just going to focus on and first, and then we'll take a look at or. So let's look at this first one. So we have a compound inequality. So I have two inequalities. And you can see the word and there. That's important. Okay, so we know what the graph of this is going to look like because we're looking for the intersection of these two inequalities. But before we know how to graph it, we actually have to solve it out. So let's go ahead and solve these two out, just like we normally would do if these were just single step inequalities. So I'm going to go ahead and I'm going to add 6 to both sides over here. And that's going to leave me with x is greater than -3. So this right here is one of my inequalities. Let's go ahead and do the other one. And I always like to just start by solving them out so that I, have the answers. So let's subtract 8 from both sides. And this one's going to be x is less than or equal to 5. And just as a reminder, that rule for inequalities, the rule being if you multiply or divide by a negative number, you flip the sign, it still applies with compound inequalities. So anytime you approach any type of inequality, that rule will still apply. Okay, here are my two inequalities. Now, I'm going to go ahead and at this point, if you're taking notes, I just want you to kind of pause and just watch what I'm writing because I'm actually going to erase it, okay? But I just want to show you what this is doing here. So the first thing I'm going to do is on my number line, I'm going to put a 0, and then I'm going to put those two numbers that I got for answer. So I'm going to put -3, and I'm going to put +5. Okay, I'm just going to represent those on my number line. Now, this is the part, don't write this down. Just watch what I'm going to do. The first inequality is x is greater than -3. So that's going to look like this. Open circle going to the right. The second inequality is going to be x is less than or equal to 5. So that's going to be a closed circle moving to the left. And because this is an and statement, I want the intersection of the two. That's what I want. So the intersection of the two, if I were to put these lines on top of one another, it would represent, I'll go ahead and just kind of highlight that area so that you can see it. It would be from here to here, and it would be from here to here. So if I were to draw one graph that would represent these two, it would look like this. Open circle to a closed circle. That's what my intersection would look like between those two. Now, I don't want to write all of this on my number line. That's too much stuff. I only want to write my final answer. So I'm actually going to go ahead and I'm going to erase these here. And I'm just going to write my final answer. So it's going to be open circle going up to a closed circle. And that is my compound inequality represented on my number line. All right, now how do we write this in set notation? This is a little tricky now. So I'm going to always start with my x such that, so nothing is different there. But now I'm trying to represent the solution to this inequality, or this compound inequality. So what I'm going to do is I'm going to look at my graph, okay? And watch what I'm going to do here. I'm going to write -3 is less than x, which is less than or equal to 5. Now let me go ahead and explain this. Notice how my lowest number is -3, and that -3 is not included, which is why I use the symbol less than. I'm saying that it's less than the variable x, so all my variable is being represented by everything on this line. So all of those numbers in between these two numbers can qualify as a solution to this compound inequality. So that's represented by the variable x. And all those values are less than or equal to +5, which is my highest number. So that's how you would represent this compound inequality using set notation. Now let's look at interval notation. I think interval is a little bit easier to think about. I'm just going to look at my graph and say, okay, well, my lowest number is -3 and it's not included. So that's going to be parenthesis, -3, comma, my highest number is +5 and it is included. So there's my interval notation. Okay, so that was our first example of a compound inequality that's an and. Now let's go ahead and look at another type of and. So with an and compound inequality, you either have the word and in it, or it looks like the one that you see here, where it has an inequality kind of like in between two numbers. This is always going to be representing and, okay? If it looks something like this, it'll always be and. Now, how do we get two inequalities out of that? Well, here's how. Watch what I'm going to do. One of my inequalities is going to be represented by this first one here. Do you see it here? That represents my first inequality. So I'm going to go ahead and write that down. -5 is less than or equal to x minus 2. And to capture my other one, watch what I'm going to do. I'm going to go grab the other one. There's my other inequality for this compound inequality. So I'm going to write that over here. X minus 2 is less than or equal to 3. You see that? So I just kind of plucked it out. I plucked both inequalities right out of there. All right, I highly recommend doing that versus kind of trying to balance the inequality, because once you start multiplying and dividing by negatives, it really messes things up with flipping the sign. So I highly recommend breaking it into your two inequalities first. All right, let's go ahead and solve. I'm going to add 2 to both sides over here. And that's going to leave me with -3 is less than or equal to x. And I'm going to turn this around so that my variable is over on the left-hand side. Alrighty, there's one of my solutions. And then here's the other one. I'm going to add 2. So x is less than or equal to 5. All right, there are my two inequalities. Now, I'm just going to go ahead and draw one graph for this one now that we kind of have the idea here. I'm going to go ahead and start by putting a 0, a -3, and a +5 on my number line. It's a coincidence that these numbers are the same. Okay, let's look at this. X is greater than or equal to -3. So I know that I'm going to have a closed circle on -3 going to the right, right? Well, I'm not going to draw that quite yet. Let's go ahead and draw the other one. X is less than or equal to 5. Well, that's going to be a closed circle again, moving to the left. So if I were to intersect these two, the only points that would be intersecting are the ones in between, leaving us with this graph. Set notation would look something like this. X such that, remember I'm going to start with my lowest number, and that is less than or equal to x, which is less than or equal to 5. And I'll give you a little tip here with set notation. Notice how my symbols, less than or equal to, they're always going to be less than or equal to or less than, meaning they're always going to be facing this direction. They're never going to face this direction, ever. They're never going to look like these ones over here, ever. They're always going to be facing this direction that you see here. And then our interval notation, we have a bracket, -3, comma, 5, bracket. All right, and that is an and compound inequality. Now, let's go ahead and look at the ors now, okay? All right, here are the ors. Now, the great thing about ors is it will always say or. Notice that both of these problems here, they both say or. It'll always happen that way. So let's look at the first one here. All I'm going to do is begin by solving it like I would a regular equation. I'm going to add 6 to both sides. And I'm left with n is less than or equal to -8. Okay? All right. There's one of my inequalities. Notice I didn't multiply or divide by a negative. If I did, I would definitely need to take into consideration that flipping of the sign, but I didn't here. And then this next one, I'm going to multiply both sides by 10. So my 10s will cancel out, and I'm left with n is greater than 10. All right. So let's take a peek here. I'm just going to go ahead and jump onto the graph. I'm going to put a 0 here. I'm going to put a -8, and I'm going to put a +10. And let's go ahead and graph. N is less than or equal to -8. That's going to look something like this. And then n is greater than 10. It's going to be an open circle going to the right. And that's it. That is an or compound inequality. Now, to represent this in set notation, remember that we have to represent the union of two inequalities. Here's how you do that. Squiggly bracket, n, such that I'm going to start with my inequality on the left-hand side. That one is going to be n is less than or equal to -8. Then I'm going to use my or symbol here, which is the U. Or, and then I'm going to represent my inequality on the right, which is n is greater than 10. That is how you indicate your compound or inequality using set notation. Interval notation is going to look like this. Notice my first inequality is going in the negative direction, so negative infinity, comma, -8, bracket. I'm going to put my union symbol in the middle because it's the union of these two inequalities. And then my upper one, which is parentheses, 10, comma, going all the way up to infinity. So you can see that the notations are a little bit more complex for these types of problems. Okay, let's try another one. This is that weird one I was talking about in the beginning of today's lesson. Let's take a look. Notice I have an or compound inequality. So I'm just going to go ahead and start by solving them both. I'm going to multiply this first one by 7. And that's going to give me x is greater than or equal to -7. Now, I'm just going to bring something up here. It's a common misconception with inequalities. Notice how I multiplied both sides by 7. But the result on the right side was a -7. That does not indicate that you should flip the sign. You only flip the sign when you either multiply or divide by a negative number. We multiplied by +7, so we're not going to flip the sign here. All right, let's go try the other one. I'm going to divide both sides by +2. So that's going to be x is greater than 20. Okay, now we want the union of these two graphs. So let me show you what I'm going to do here. Now I'm going to start by putting my numbers on my number line. So I've got my 0, I've got -7, and I've got +10. And for a moment here, don't draw this. I'm just kind of going to show you what's happening here. The first one that you see here is x is greater than or equal to -7. So that's going to look like this. I'm going to have a closed circle, and I'm going to be moving to the right. Again, don't write this down. I'm just going to kind of show you. If you want to write it down, you can, but I just wanted to show you how it works. And then x is greater than 10. Let me go ahead and do that again. There we go. And then x is greater than 10. So I'm going to go ahead and do this. Open circle, going to the right. All right. Now, this is where it gets a little confusing. We are looking for the union of these two graphs, okay? The union, all right? Not the intersection. So be careful to not indicate the intersection here. We want to account for all of the points on both of these two graphs. And the way we would do that, we would kind of pull it all together. And I'm going to do it in orange here. But I'm going to say my lowest point is my -7, which is included. And I'm going to represent all the points going to the right. Because that line takes into account this one right above it. So it accounts for all these points and it accounts for all these points. You might have the question, well, this is an open circle right here. So shouldn't that be open right there? No, because if you look right above it is a closed circle, and a closed circle always trumps the open circle because that's basically a point there. Okay, so we're only representing this answer by this orange line that we have. So I'm actually going to go ahead and erase all this up here because your answer would just look like this here. So you got to do some thinking there to kind of piece it all together. Now, how would we write this in set notation, interval notation? Well, x such that, think about what this inequality represents. Isn't this really just x is greater than or equal to -7? Isn't that what this represents? So let's just go ahead and write that. Once you combine the union of the two, well, you just really have one inequality to represent, which would be represented by bracket -7, comma, infinity. All right? So those show you two different types of or compound inequalities. Now, this lesson would not be finished if we didn't have special cases. So, of course, we have two special cases. Let's take a look at them. So looking at this first special case, you can see that it's an and inequality, isn't it? It's and we know that because it's got like this inequality in between two numbers. So here's one of my inequalities. There's 1. I'm going to go ahead and write him down off to the side. And the other inequality is here. Okay, so and I'm going to represent that by 5 plus n is less than or equal to 3. Let's go ahead and solve it now. I'm going to subtract 5 from both sides. So I have 0 is less than n, and then n is greater than 0. So that's one of my inequalities. Let's go check out what the other one is. I'm going to go ahead and subtract 5. So I've got n is less than or equal to -2. Okay, so there we have it. Now, it looks like a regular inequality now, doesn't it? Now, let's take a look at what this looks like. Let's look at it on the graph. I've got 0 and I've got -2. So that's really the only two numbers that I can put on there. So I'm going to go ahead and graph this out and show you what I mean. N is greater than 0. Well, that would be represented like this, wouldn't it? And n is less than or equal to -2. That would be indicated like this. Filled in circle going to the left. And you have to remember what and means. And we know this is and, right? And you have to remember that and means intersection. And because these graphs do not intersect, there is no answer to this problem. There is no solution to this problem because the graphs do not intersect. So having that said, I actually don't want to graph anything because this graph doesn't really mean anything. You actually can't show a graph for this one because there's no solution. They don't intersect, so there is no graph. Set notation, well, we don't have a set notation for that or an interval notation for that either. So that's one special case. I bet you can guess what the other one's going to look like. Let's go ahead and look at the other one. I'm going to start by looking to notice that it's an or inequality. So I want a graph that's either both arrows are going in the opposite direction or both of the arrows are going in the same direction, like the examples that we did previous. So let's remember that this is or, so we're looking for the union. All right, I'm going to go ahead and divide both sides by -6. Since I divided by a -6, guess what? I've got to flip the sign. So x is greater than or equal to 1. If you happen to forget to flip the sign, it's going to affect the entire problem. So you have to be very careful with those details. All right. And then, of course, the other one, let's go ahead and do that. Subtract 9 from both sides. And I'm going to be left with x is less than 5. There it is. Now, let's go look at it on the graph now. I've got 0. I've got, actually, I'm going to move that 0 over a little bit just to kind of even things out. I'm going to do 0, I'm going to do 1, and I'm going to do 5. And let's take a look here. X is greater than or equal to 1. All right, now just watch what I'm going to do. I'm actually going to erase this, but I want to show you what I'm doing here. X is greater than or equal to 1, so that's going to look like this. X is less than 5. Well, that's going to look like this. Now, we have to remember this is an or inequality. So we're looking for the union of the two. I want to represent all the points on both of those graphs. And the only way to do that is to say, well, every single point is represented, which is all real numbers. And of course, I want to erase this up here because I don't want that represented in my problem. The only graph that I should have written is the graph for an all real numbers, just like that. All right, so I'll go ahead and write that down. All real numbers. All real numbers will fit into this compound inequality and satisfy both inequalities. Set notation, well, set notation would look like this. X such that X exists in the real number system. And my interval notation will be -infinity, comma, infinity. So in this lesson today, we just talked about what compound inequalities were, what and or look like, and we even included those special cases. There are quite a few details in this lesson, so feel free to watch this again at your leisure and make sure you pick up on all those little details that we talked about.